So, some people think that textbooks and books are going to disappear from the education system. It's all going to be Kindle and stuff like that. I think because of the field books and eye strain and how technology develops and stuff, that they're going to be around for a while longer. And, but I could be wrong, and still play a significant role. However, and I'm talking about like traditional paper textbook, but if they're going to be around a while longer, it might make sense to actually improve them. And maybe if you improve them, that means the competition has to get even better before there's a total replacement thing going on. So I want to talk about some ways I think we can improve the textbook technology of a hardcover textbook. One idea is to make it anti-stain textbook. And having an anti-stain textbook means that it could last longer, which means people paying less to replace textbooks. It could be better for the environment, because you replace them less, and for disabled people, other people that might have more likely to spill food on it or liquids, stuff like that. Stuff which is all good and stuff. One way of making a textbook more anti-stain would be to incorporate little ceramic or clay nanoparticles into the process of making the paper, or certain natural compounds found in plants that help repel water, like waxy substances. These little ones will form little structures that cause water and other liquids to ball up and not actually contact the surface, while also protecting it from damage. This especially also will be useful for like poor people or people that cannot, because their textbooks are more likely to get damaged because they have worse living conditions, but it's also hard for them to replace. And it won't take a lot of money to add these little nanoparticles here and there to some degree of better. For us, now degrees of improvement are always a thing, from 0 improvement to 10 billion times. I just made up that last number. So like doing a couple times better is easy, but each additional one is a lot harder. And the reason why I talk about organic ones, wax or clay or ceramic ones as an improvement, not other ones, because those chemicals are relatively safe, to perfectly safe. Another idea that kind of goes hand in hand with the anti-stain idea is to make textbooks more erasable. And by that, I mean that you can take a textbook and you can write on it with a pen or a pencil or a highlighter and then erase it later on without damaging the actual textbook that much. And that would let people also take better notes. In the future, other people see other notes. It might help with note-taking stuff, or just promote note-taking. And this is also could be useful for people that are out there that are so poor they can't afford new paper or much paper. Those people exist. Or it's in cost, so if they can use paper more often, in general, it will be a great idea. And all these ideas also might apply to just paper in general. I want to point that out. Now we can use very similar technology to the anti-stain textbook I talked about before. We can also make it so that liquids and stuff that enter the matrix only enter much more the surface, and the surface layer gives off stuff more easily under certain conditions. Or you could do the opposite, redesign pens and pencils to work better in that way. Now, making it more erasable also comes out with the problem that if something is more erasable, it also becomes less permanent. So that might be a con for using this as just paper in general. Another con is that it might smudge a little more if you close the textbook and move papers around. I don't think that's the biggest problem with smudging at times, because if you close two sheets of paper together, for a textbook, you usually don't put the textbook so the sheets of paper are rubbing against each other. It's much more like they just collapse on each other. It could be a little problem. And also with the anti-stick, the paper and nanoparticles, papers are not as much actually touching each other, because there's little surface structures that push them off. So I don't think that's going to be as much a problem, but we'll see as people develop it. Another idea is to have it all waterproof and stuff, so it's actually washable. as a quick way of cleaning it off from stains and everything. It's more of an extreme idea if you spill stuff. And then now having a washable textbook that's waterproof means that you can make it a little less erasable and stuff like that, and still have the benefits of being erasable. But then again, someone has to have a washing machine and stuff like that. That might cost more money, or they have to scrub it with a water and stuff, which might use up water. So there's pros and cons there. Excuse me. Another idea is to have placeable pages in a textbook and stuff, which, if a page is damaged badly, could be a great idea. It could also mean that we can put more updates and stuff like that, or give out individual sections of a textbook. And you can imagine this as more replacing textbooks with more binder-like things, and also having replaceable pages and pages you can take out and put back in like a binder might also mean that you don't take the whole textbook with you all the time, which might make it lighter and more transportable, especially for people with disabilities and stuff, so they can actually carry the textbook with them. It could also mean that if you want to carry multiple textbooks at once, you could combine them in one huge, gigantic textbook. Or you could issue your own collections and replace pages with them. And there's all these other possibilities with replaceable pages. Another idea I want to emphasize is to make this whole thing incineration safe, I'm going to call it. But basically, when you're really desperate, you might want to burn a textbook for fuel or something like that, or the cooking, or you might burn it. Some people just burn, I know, textbooks and stuff, and it might be seen as a little wasteful because they're done with the course and it's over with. But also, this is a way of disposing of waste that can be argued whether it's better than just putting it in a landfill, because if it did turn into good solid soil, that's great in landfill. However, what oftentimes happens in landfill is it doesn't decay because of all the trash and stuff suffocates it out. And also it doesn't turn into really or it suffocates out other stuff, making other stuff harder to decay. And also if it decays in a certain way, it makes some methane gas and other greenhouse gases that are more potent than CO2, or gives off a little CO2. Now if it decays in soil and promote plant growth, that'll be a different cause. Now if you burn it, you just turn it into CO2 and you produce some energy, not the most potent greenhouse gases. So it's complicated. But if you incinerate something and it produces a lot of toxic fumes, no one's going to argue that those toxic fumes are good. There's a bunch of ways you can make this incineration safe, to make sure that it doesn't hurt you. First of all, there are some, not including any elements that burn and make toxic chemicals. These are heavy metals, burn, some halogen chemicals are usually in that. Halogens are like chlorine, fluorine, stuff like that. Sometimes they don't really burn, sometimes they do. But if they burn, they can make a lot of toxic fumes. Another one is sulfur. It can burn and make toxic compounds. And those are really the primary ones. Now, carbon, hydrogen, oxygen, and nitrogen all can be safe or cannot be safe. If they turn into CO2, H2O, and nitrogen to N2, it's perfectly safe. CO2 is everywhere. Its only danger is in global warming or if it suffocates you. But in the well vented, that's a problem with anything burning. H2O is just water. N2 is what's everywhere in the air. Now, if nitrogen doesn't completely burn and turns into nitrous oxide, that can be dangerous. Carbon monoxide, if it doesn't burn completely, makes carbon monoxide, which is dangerous. And then other ones is if it makes a lot of little particles that go into the air. Those can be very, very dangerous because they're just breathing in any small particles. So you want something that burns very cleanly and nicely. And that can be done. If you want to look at the certain things called nitrocellulose, which I'm not saying we should use, nitrocellulose has many wonderful properties. However, it's highly flammable and highly explosive, but it burns very, very cleanly. That's one of its advantages. A funny story is that they actually tried to make clothing out of nitrocellulose because they used to produce it as rocket fuel and explode and ammunition for some of the wars. And after the wars, they had leftovers. So some great American companies, and I'm being sarcastic there, tried to make clothing out of it, and the clothing just combusted and exploded on people. No one was injured because it just wasn't enough to really hurt them. Well, I mean, badly injured, but people just suddenly burst into flames and the whole clothes disappeared. But the point is not nitrous stuff. You can't make clean burning stuff. You can also make stuff that burns, but doesn't. This carbon stuff absorbs. First, there's carbon or clay or ceramics that absorb the harmful smokes and fumes, and are not sized that they don't really irritate the lungs and stuff, so they stay off back in soot, the unburnable stuff, or they burn later the carbon as like a charcoal or something that burns more cleanly, but first they absorb the toxic stuff. And but that later on, when it burns more completely, it's not toxic, it's nitrous oxide. So there's a bunch of ways of doing it that way to look at. Another one is to have textbooks with better page navigation. By that I mean, it can be really hard with a lot of science textbooks to navigate in a science textbook because they'll be like, look at figure 2A, but they won't tell you what figure 2A is in the textbook. The problems are even out of order of seeing and stuff like that. So it's making it very clear where everything is located in the textbook. We're giving exact page numbers at the very least, or making clear-cut sections, or maybe even just reprinting figures or something like that in more places so you don't have to go through them as much. Stuff like that, or clear headers and titles on top. Well, thank you very much for listening. Please like and subscribe. We really have 10 out. I'm trying to hit the top 1,000 subscribers in the 4,000 watch hours. This is really hard, really help I think to do it. Again, thank you much. Goodbye.